Merry Christmas, everybody! Welcome to the Vintage Computing Christmas Challenge 2023. This time you had to create a Christmas mesh, a certain shape which you just can see on the screen. There has been a plethora of entries which will be shown shortly, and there also were some wild entries which will show in between. On the right top there will be a number which shows you which entry we currently see. If there are several entries on the same rank, or let's say with the same size, they are not sorted. I will explain more on that later, and expect a lot of entries, even more than the last time. So now let's start. These were quite a lot of entries getting smaller and smaller. You've seen many languages, exotic languages like Logo, Force and Plasma, but also many basic entries on different machines. There were many vintage machines like from Enterprise MSX, Commodore of course, Jupiter Ace, TRS-80 Model 100, BDP, Amstrad, Amiga, Sinclair, BBC, IBM mainframes, Atari, MS SQL Server, homebrew stuff, BBS, Famicom, aka NES, and even calculators and virtual arcade systems. So, thanks to all participants. I hope you enjoyed the task. I hope it was not too difficult, and I hope you had I mean, oh yeah, that's what I meant. Thank you, Shakin Stevens. And by the way, nice letter you have. Well, after seeing so many programs, maybe it's interesting to see how this could have been implemented. There are several algorithms that come into someone's mind when you look at the shape. So let's look at a few of them. First of all, you could just see it as a square with an x and y dimension, and each position would be either a space or a star. You only have to find out the formula, whether it's a star or not, 0, 1, or even yes or no. Another possibility would be to check out line by line if there has to be a star or a space, or where the spaces have to go to. There can be 3 or 6 stars, and between them there are spaces, obviously. You can count that and try to find out 1 or 2 formulas to check the distances. While it looks like quite a lot of numbers, but actually it's not so many numbers, and it's many numbers 1, 3, and 5, and some 2s as well. Another possibility is to see it as 9 diamonds with have one problem. The problem is that there is an overlapping, and if you do not consider the overlapping, the shape would look a little bit different. And well, you could solve this overlapping problem in certain ways. One would be that you just say, I make the diamond a little bit smaller, I cut off the right and the bottom star, and then I can merge this. But then you again have the problem that there is an additional star at the end and on the bottom, which you gotta solve somehow. This will play a role in some algorithms. So, moreover, you can see different shapes. You could not see the 9 diamonds, you could see a huge diamond, and additionally some rectangle which go diagonal left and right. All together would give this shape then. Another possibility is to see slashes which go backwards and forwards, and if you merge these slashes, they will go and give you the shape that we all are looking for. And there are even more possibilities. Let's move on. Another possibility is to see a zigzag shape which goes up, down, up, down, up, down, and down, up, and down, up. And if you merge these 6 lines, you just get the shape. So you could say, well, these are 2 kinds of zigzag shapes, but you could also say it just 2 lines, namely a line up and a line down, and you only have to put these lines together, which consist of 3 or 4 stars, however you like to implement it. And yeah, finally you also get our crystal mesh shape. And the last possibility I want to present you is that you could see it as axes. Yeah, it's not diamonds, there are axes and half axes. For example, you see the yellow X and the red X and the green ones and the bluish ones. And this also allows you to use different formulas, obviously, which might make your life easier and safer by the two. So that's it about the algorithms. Again, many different kind of entries, different language, but it usual lots of basic and assembler entries. The more extraordinary ones were like Scala from the PC, Lua, C, Plex on the Plasma, and the just last one, the Mega 65. Now let's look into the wild section. I will give you a short overview of the entries. Later on you will see most of the entries in more detail. So let's go on to the normal standard size coding entries. have just seen some more fantastic entries for different machines. I sadly cannot go deeper into each entry because I think this would take ages to analyze each entry and to see where was the best entry for BBC, for Amstrad, for Commodore and in assembler and in BASIC or whatever. So let's go further. Further in this case means let's look into the right entries, which we have seen before already. Here we see an entry by Potender. It's for the Commodore C64 using the VIC-64. It uses the Vice emulator which supports the VIC-64 and, well, it tries to download the shape from the internet using the VIC-64. If it's not there, you have to configure the Vice emulator and just add it, and after that, voila, it's working. And well, the code surely is a little bit longer, but it's very flexible, so for the next shape he only has to exchange the shape on the server, and that's it. Well, a cool solution, isn't it? So many great and wild entries, and one is still missing. But well, we have to move on. So let's see more standard size coding entries.
Dixon and all his reindeers pulling on the reins. Bells are ringing, children singing, all is merry and bright. So hang your stockings and say your prayers, 'cause Santa Claus comes tonight. Here comes Santa Claus, right down Santa Claus Lane. He's got a bag that's filled with toys for boys and girls again. Hear those sleigh bells jingle, jingle.
Step by step, we are reaching to the top entries, the shortest ones. We've just seen over 200 entries, and the last entry was just 40 bytes. And we also saw the smallest basic entry by David Payne with 41 bytes. I think it's a good time now to compare the languages a little bit. I do not want to go too much into detail, but we know that Assembler, Basic, and APL are very different languages. Assembler is CPU level, and you can make the problems very short, while Basic is a little bit longer but more comfortable, and APL is a very specialized language, especially for data manipulation. And therefore, usually APL is extremely good to make the size very small, and Basic isn't that good for that. So keep this in mind, and if I would have to compare three programs with the same size, I would say that APL definitely has advantages, and therefore Basic would be the language I would consider as the biggest effort someone had to put in to make it so small. Then I would see Assembler and then APL. So, but the last and the smallest basic entry already has been there, so let's move on. Well, what you see here now is a 3D model of the formulas that we have discussed earlier. You see the alternating numbers from 3 to 1, 0, 1 to 3, 3 to 1, and so forth on the x and on the y-axis. And on the z-axis you see the numbers of the sum, meaning they are from 0 to 6. And if there are 3, then we do have our diamond shapes, which you can see exactly now. Yeah, so you can see you can think of the things differently, and this is the way how you could view it as 3D dimensional object. I have also made another model, which I will just show you shortly, which will not make it like this, but like this. Yeah, here you see exactly the same, but it uses just the value 1 or 0 and doesn't make this kind of like mountains looking shapes you've seen before. And still here you can see very well when something is a star, namely the blue pics that you can see, and if it's a space, that's the red areas that you see in this picture. Well, maybe it's a help for someone just to imagine how this diamond shape for this Christmas event looks like in 3D in this case. We have just reached the 30 bytes border and we are coming close to the end. Before we reach the end, it's a good time to watch the 1 byte, the 1 cut solution. Merry Christmas! So, did we reach the top already? No, we didn't. We still have some entries left. And I can say the next one is Dr. Beep. He entered with 2 entries because they are so good and only the better one will count, of course. Yes, I also had some fun with APL with my entry, but let's move on. Let's see the top of the top. Actually, we have 3 number ones. As we know, this is a challenge, not a compo, so I don't call them winners, because there will be a small surprise afterwards. But well, let's start with one of the first entries, which is Paul 7 with an APL entry. Don't get confused with the basics. So, how did he create his entry? This is the formula he created in APL. And now let's dig into it step by step. First, he made just a simple list with 6 values, 1 to 6. This, of course, is not enough, so he is comparing it by 4, so only the number 4 will become true, all others are false. Like in the bus, 1 is heading his hand. And so after that, he makes a partition with 19 times 19, which is a little complicated. So let's see the partition of 19. Of 19, it's just this row of 0 and ones 3 times and 1 more. And then he does the same, and it's shifting to the left always a little bit. And when you do this not 3 times but 19 times, then you get the diagonals, which we were talking about already today. So from this, it's not a big step to get to the final shape. He is saving it into the variable t, so nothing much happens, it stays the same. But now he's able to do something with t, namely, actually now he is inverting it. So the lines, the diagonals show in the other direction. And well, that's finally the clue. Now he only has to make an OR with the other diagonal and he gets the shape, and replacing the ones with stars, the shape is there. And now we already reached the next entry, which is a J entry, a language I didn't know before. It's kind of similar to APL, just a version without Greek letters. And now we see he uses another formula. He creates the values from 0 to 18, then he squares it, then the squares are quasi reduced by the y values, which are the same values, and these values then get the absolute values, and then these values get the modular operation by 6, and here you already see the shape we all wanted, namely it are the 3s he compares with 3, and now the true or the 1 values can be replaced to stars, and we have the shape. Simple like that. Well, not really simple, but it works, and it even works without echo, which would make it smaller, but then it wouldn't be a valid program. And here, the best and shortest assembler entry by ArtTop. In 23 bytes he achieved to create the shape. How did he do it? As he wrote, he did following. He made external cycles for the calculation of coordinates. One of the coordinates decreases from the initial value to the value of less than 0. When the value is reached, meaning it's less than 0, then the offset is added to the coordinate, and second coordinate is reduced by 1. When 0 reaches, the program stops, and the inner circle, the asterisk output circle, he does following. The program prints the asterisk, mirrors the coordinates, and prints the asterisk again, and this is repeated several times. Although we have seen 3 number ones now, the show isn't over. It's still going on, but before we go to the last entry, the missing wild entry will just come now. This is actually also the winner of the Wild Combo, so congratulations! And now to the final entry. It was planned to do this entry as a wild entry, but on the other hand, it's also a just normal entry. It's an entry with a special language, and I talked with the author and he said he would rather put it into the wild entry because it's not really a fair competition. It uses a stack-based ASCII art language, which is called Canvas, and the author is Patrice Carré together with Zyma. Yeah, so let's look into this entry, which in my mind is not the number 1, but number 0. Here we have the development environment of Canvas, an online app. We write 4 stars, then we can just execute it, pressing Ctrl Enter, and we have 4 stars. No command needed. We add a slash, and then they will just look like a slash, the 4 stars. Then we add this cross sign, and we already have a diamond with only 6 bytes. After that we have to add some commands, and well, we get 3 diamonds and the overlapping problem is solved as well. And doing this one more time, we have the whole diamond shape with the 9 diamonds. Fantastically short, with only 17 bytes, shorter than any other solution. But the solution is also specialized for ASCII art. Well, and that's it. I'm really exhausted. Over 200 entries in the main category, several hundred emails which flood into my mailbox, and many conversations. Coding myself was fun too, but I actually had not enough time for that. Creating the video took much more time than planned, and there are surely some errors, I hope not too big ones. As far as entries are concerned, reach out on me. I could exchange the entries if you have some serious bug or missing information. The video itself will just stay as it is. Now you are surely curious about the programs of the others, how they implemented it. I'm gonna try to put them online as soon as possible. And something new, I decided to make a post-entry phase. As already someone contacted me and said that he made a better version of his program, and well, let's give a possibility to put those post releases together where they belong to, and I will just create a own post-production category for that. So that's it. I wish you all the best, a nice Christmas time, and hopefully a great new year 2024.